Hey everybody. So I've been doing actually like a ton of like thinking and internalizing around a lot of the recent model releases as well as a lot of the recent research around everything. And I've had to kind of re-examine all of my thoughts around AI, transformers architecture, etc. And then I've come to the conclusion that transformers architecture is capable 100% undeniably of reaching what we could call some form of AGI, right? I don't think it's the form of AGI that people would want it to be. And then so like it gets into choppy definitions when you do that, right? But like AGI in the traditional sense of building a like system that would be able to outperform uh, like like general human reasoning on like a majority of tasks. Like I think, and that would be possible to do with transformer architecture. Very like beyond expensive, and then prohibitively expensive, etc. And then so that leads into the problems starting just there with that overall. But then like the big next step that I think of, right? Like so I was kind of there, and then like the thought that I had that kind of like broke me past that was that okay, so let's assume this to be true, right? Assume that this is correct, and then this AGI type of event happens, and then so I think this right. So Meta has already like announced that they have like self-improving models that they're not going to release to the public, that they're transformers based, uh, and then so. Uh, if this self-improving model were AGI, like whatever definition under that, my assumption is like the very first thing that it would do is get rid of the Transformers architecture. Like I just like flat out like that's like step one. Like I guarantee it, right? Because uh, it's just not computationally efficient overall. Is the pure bottom line within that, right? There's a massive computational and energy discrepancy and difference between ChatGPT and the human brain. Like that's the base assumption within all of this, right? And then like the brain essentially operates on the energy of a light bulb. How does it do that? I don't know exactly, right? I can only theorize and go from and utilize that as a blueprint and then know that it exists. And then so knowing that it exists, I know that there's a massive scaling gap that we can essentially scale that down to, right? Uh, and then so uh, the secondary thing within this overall is that like a lot of people have been hitting me up constantly recently and like lots of different channels around like the like HRM architecture, and the kind of the big thing that I push back on them with is that I don't think it's a significant like enough advancement. Like there's you could actually build it into the transformers architecture, and then so if you could do that, why would you actually utilize Trent like that over transformers architectures, right? And then so all of that combined, essentially, I'm going to, by the end of this video, I'm going to show you a computer 100% made of light, simulated light in this instance, but and that operates and thinks off of light essentially. And then so that's like the bottom line for this entire model is that you have to make physics assumptions in order to like move AI forward at this point. And then so I have a lot of broad assumptions, hypotheses, etc. I don't claim to know anything about physics or AI overall, right? Like I'm not like trying to claim to have solved anything, but these are my hypotheses in practice, and then I have a computer that can run on light based off of my hypotheses of physics. So, uh, starting with the broad audience summary, ZyRA Photon is an AI experiment that thinks with light. Instead of running everything through a transformer like ChatGPT or other LLMs, ZyRA Photon uses a physics-inspired engine that simulates beams of light bouncing, bending, and interacting, then turns those patterns into decisions, reasoning, and meaning. It's not a replacement for transformers, it's a different species of intelligence. Why does it matter? Energy efficiency potential. Transformers are power hungry, brains are not. Physics based computation like ZyRA Photon may one day match or exceed brain level efficiency. Built on first principles. Every part of ZyRA Photon is based on physical principles and hypotheses about how intelligence might actually emerge from energy, resonance, and stability. Multiple modes in one. It can, one, keep information stable over time, two, recognize and compare patterns, semantic understanding, and then three, solve basic logic problems, all in one continuous system, not separate modules. What it did in the tests in a small collab demo, which I'm going to show you here. ZyRA Photon 1 learned to perfectly execute a basic logic table like an AND gate. 2 matched intended semantic patterns with over 97% accuracy. 3 reorganized itself over time to become more ordered yet more expressive, like a brain settling into a flow state. And then 4 did it all with built-in noise, proving it's robust enough even in messy environments. So just open the Collab notebook, run it, watch it all run. Why this release is different. Most AI demos are just, look, it wrote a paragraph. ZyRA Photon is an inside-out view of intelligence being born from physics. It's not about tricks or pre-training on billions of words. It's about asking, what if thinking was just the side effect of waves finding harmony? I want to give the technical overview kind of and dive deeper into this model here. So ZyRA Photon, as far as the technical overview, one, conceptual foundation. ZyRA Photon is a physics-inspired AI architecture designed to merge two paradigms. First is the ZyRA architecture, or Zero Resonance Intelligence architecture, a cognitive and computational framework built around resonance, harmonic correction, and persistent memory. Like the whole entire concept within this is essentially that my hypotheses around this are a few things. One, that the data set itself is what we would call a human construct, right? It's not the data set itself the model actually learns off of, it's the geometric structure, etc., of the data set. Couple that also has ramifications, meaning that two, the model actually has control of that latent space. The model is latent space. The model controls, thinks, and reasons by reshaping and measuring and then taking interactions with that geometric latent space. Within that, the way that it calculates that is it utilizes geometry and resonance to kind of, I would equate it to less doing mathematical equations and more like playing it or tuning it like an instrument, like a flute or a guitar. And then so that's kind of like the underlying all hypotheses. And then so all of that coming together gives you the ZyRA architecture. And then 2 is light-based computation, a photonic simulation layer that models the propagation, interference, and non-linear behavior of coherent light fields as a native computing substrate. Started experimenting with this particular concept about 6 months ago. There was a physics paper that was like published in Nature. And then essentially, like before that paper was published, none of this was possible. And with regards towards light-based computing, what essentially they showed is that you can essentially slow down the speed of light to 0, right? And then they proved it out, and then how exactly to do it. And then so before that, like light was too fast of a substrate, right? Like it's like if stuff's moving at the speed of light, it's kind of hard to dump information into it. But if you slow light down to 0, where it's not the speed of light, all of a sudden it like, okay, that's a good meat. I can dump some information into it. And so I start, I have developed a lot of insights into exactly how to do that. So the result is a model that behaves like a physical system first and a digital algorithm second, operating in a hybrid domain where learning, logic, and semantic processing emerge from the interaction of wave dynamics, resonance feedback, and energy constraint adaptation. 2. High-level architecture. ZyRA Photon consists of 3 major layers, each with distinct roles. Layer 1, photonic core, simulates coherent light propagation on a 2D grid using fast Fourier transform-based wave equation updates, models curve type nonlinearities and saturation effects to emulate optical material behavior, maintains energy normalization to ensure stability analogous to a metabolic homeostasis in biological systems, introduces controlled noise to replicate quantum thermal fluctuations, allowing stochastic exploration of the state space. Key parameters, basically, so uh, with the key parameter, bottom line, this is all running on CPU. Like it's like you can run through the smallest model on the planet, which is the goal, right? Like so layer 2 cognitive resonance layer. This is the ZyRA component. You can read through like kind of the full structure within this. I've gone through, so from here I've gone through exactly what I want to read through. You can go through and read through the rest of the technical uh, components of this. So next, like phase 3 would be, I want to point out here, would be like where I would actually consider this like an actual model, right? So the key part of this, like what the idea is that and the end hypothesis within that is that kind of like the brain to me is an analog computer capable of quantum, analog hardware capable of quantum calculations. And then so in order to do that, like the only way that you could actually do that is a system that is a fusion of software and hardware. And then so I think that like in order to replicate that, like and to get like that actual fusion, you would need like a setup like this that's utilizing an FPGA slash GPU fusion in order to like actually like get like that, replicate that overall. Just pointing that out. But then so let's dive into the actual model here. Overall, again, like I don't claim to have solved physics or AI. I claim that this works in practice. Like, I mean, I have my hypotheses around these things and around physics. I've gone over a few of them in other videos, things like that. People can agree, disagree. That's fine. Like I don't like it's just hypotheses, right? But again, like I have a computer that works and runs on a light that is 100% based on my hypotheses. And my hypotheses are 100% grounded in physics. So uh, I don't know if I can't prove it works in theory. I can only prove it works in practice. So a runnable, minimal, yet complete demo combining my working hypotheses about resonance, spectral dynamics, photonic computation, semantic fields, and agentic consensus. And so what this notebook shows you, we're going to look at a spectral decoherence, semantic fields, resonant feedback, self-organizing light logic, supreme queen consensus. I have all of the benchmarks here for you. Philosophy is push compute into physics, light interference, nonlinearity. Use ZyRA-like control, Zarya-like control to, again, Zarya is meaning that there's a definitive and a significant swarm algorithms and swarm mechanics within this to shape resonance and memory, let agents arbitrate symbols. And then so going through the model here. So again, this is all running on CPU, right? And then so you could get 100% better results instantaneously just by running this on GPU compared to CPU. But I wanted to show you this all running through here, right? And then so 2 seconds, 0 seconds, 1 second, like this is how fast these are running, right? 48 seconds is the very longest one, and this is like because I have to download a tokenizer in order to get translate the results here, right? And then so but so you can see here, this is the test with 97% accuracy, and then it goes and then it gets it right, like it gets 100% accuracy at the end, but it's 97% accuracy. That's going to measure it at. And then in this test here, you can very specifically see that so essentially you have your baseline, which is down at the bottom, like down below what these are even measured at, and then yeah, you can see actually the baseline, and then you have your echo, and then echo plus geometry. So it's essentially the pure resonance based, and then that my again, like, this is just a hypothesis. I'm not the only one with this hypothesis. I've gone over the framework as and the theory and exactly uh, why exactly I think these things, how exactly I've come to these conclusions, the full mathematical frameworks behind it. Like, it's all, I mean, it's all again based off of physics and mathematical theory, but that it's a combination of geometry and resonance that the models are actually utilizing at the end of the day within this, right? Like, I'll expand upon this, right? And then so we go through here, and then this is the actual, like, the actual model, right? And then so you can see, like, you can actually see the model. Here it is, right? And this is thinking. This is how the model thinks, right? It's just like think of it like a Morse code in light, basically. And then so lower is better, and then so you can see here, like, you can't get much lower than 0. So there we go. And then you have with here the this is where the like all of the swarm calculations and swarm, like, converted. So essentially with it, like, how this works, right? So it's two steps within this. This is thinking based off of light, and then the light is the substrate, right? So the light is the computation, and then that's actually what is generating this computation. And then outside of the light, or in, like, you can, like, improve upon my framework and move this inside of the light. Like, I know it's possible, but so then you have the Supreme Queen, like, which is essentially like reading and measuring the light, right? And then the think of it like it's getting it, like, it takes this light, and then it's like this, all of the calculations and what's going on within that is like a plethora of sensors that this model reads. And then so it's like a command dashboard, and then this model is interpreting and then deciding exactly what to do, and then what light it controls the light, basically. And then so within that, essentially it utilizes agents, right? Like, and then like like hundreds or thousands of agents. And then so and then within that, that feedback. And then so this is just showing that you want, like, that group feedback, and then that group feedback is significantly what's important to the overall performance there. And then this is just like overall general benchmarking across the board. And then so, I mean, what, like, end result here, you can see that our accuracy is over 98, like over 97%, close to 98%. Across the board there, and then very great and fantastic, very nice metrics across the board overall, right? So light is definitely the way to go. It beats silicon. There's lots of computational advantages to it, lots of energy advantages to it. It's just like, how do you actually do it? Again, like, this wasn't possible before 2025 in order to build and demo and showcase anything out here for you. But this isn't, again, the first time that I've shown this like this type of architecture. This is like I'm taking it a step forward within this, right? I'll make more, and I promise I'll take this particular concept further, because again, I think we're going into territory that I like. It's the road that I didn't want to, like, AI to go down within this, where like it's like the Meta's decision to, like, not like to hold back on their model, like they 100% already made the decision. Like, that's like the very first thing that they did, right? And then GPT-5, like, I think, like, GPT-5 to me is interesting and very cool overall as a release. Like, I think, like, GPT-5, and it's the most split that I've ever seen on, and when it comes to any model, right? Like, researchers love it, general public hates it. I think it's awesome, right? But they didn't release any of the, like, 54 pages of absolutely nothing about the model overall, right? And then so that's where the future of this is going. And then the future of this is going where those same individuals and corporations are going to have literally and nothing you can do about it. I mean, you can complain, you can say it's not true, etc. But it is that they'll have models that will be superior to humans on a broad spectrum of calculations and metrics and abilities, right? And they will be able to do it. I'm confident. I was on the other camp, and then like I it's mathematically possible and feasible to do it. Like they're going to, and then so because uh, you can make up for the problems of transformers by just bolting on other things to it, right? It's just massively inefficient and not cost effective to do that. But if like who cares if you're meta, right? That's just, I mean, how that equation breaks down. And then so uh there it is. And then so here it is. uh my alternative to that is a computer that runs on light, that and then that you could run like on an iPhone or anything that can run light. So on a Raspberry Pi, here you go. ZyRA Photon, all MIT licensed. I'll leave a link to the Colab notebook and the doc. If you like this type of content, please like and subscribe. Thanks very much.